93% of people who start a machine learning course never finish it. Not because they're not smart enough. Not because the content is too hard. Because the content is in the wrong order. They get fed theory before they ever see a result, and they quit before the good stuff even starts. In the next 10 minutes, I'm going to walk you through a machine learning playlist structure that actually works, one built around momentum, not martyrdom. You'll learn exactly which concepts to tackle first and why, which free tools to use so you're building real models within your first hour, and how to structure your learning so each video in this playlist clicks into the next like Lego bricks. And at the end, I'll reveal the single concept that most beginners skip entirely, the one that separates people who just watch tutorials from people who actually deploy models. Stick around for that. It's worth it. Let's start at the very beginning, and I mean the actual beginning, not the one most playlists give you. Most machine learning playlists open with linear algebra, eigenvalues, matrix decomposition. And look, that stuff matters eventually. But leading with it is like teaching someone to drive by starting with internal combustion engine theory. You'll never get behind the wheel. The first thing you need in any solid ML playlist is a working mental model of what machine learning actually does. Here it is in one sentence: machine learning is pattern recognition at scale. You show a system enough examples, it figures out the rules itself. That's it. A spam filter isn't programmed with rules like, if the email says free money it's spam. It learns that pattern from 10,000 labeled examples of spam and not spam. Your first video in any playlist should demonstrate this with a real, runnable example. The iris dataset classification problem is the classic starting point for a reason. It's small, 150 data points, 4 features, 3 output classes, and you can build a working classifier in about 15 lines of Python using scikit-learn. You run it, you get a result, you feel the dopamine hit. That's what keeps you watching video too. And here's where it gets interesting, because once you've seen a model work once, the next question is always, but why did it work? That's exactly where your playlist should go next. Section 2 of any good machine learning playlist covers the core algorithm families, and you don't need to learn all of them at once. You need to learn 3 categories first. Supervised learning is where you start. You have labeled data inputs with known outputs. You train the model on those pairs, and it learns to predict outputs for new inputs. This covers the most commercially useful use cases: fraud detection, image classification, price prediction, medical diagnosis. Unsupervised learning is where things get weird and fascinating. No labels. You hand the algorithm a pile of data and say find the structure. Clustering algorithms like k-means will group your customers by purchasing behavior without you ever telling it what the groups should be. It discovers them. Companies like Netflix and Spotify use variations of this to build recommendation systems worth billions of dollars. Reinforcement learning is the one that looks like magic. An agent learns by interacting with an environment, getting rewarded for good actions and penalized for bad ones. This is how DeepMind's AlphaGo became the best Go player on the planet, not by memorizing moves, but by playing millions of games against itself. We're not starting here, but knowing it exists changes how you see the whole field. Did you know that as of 2024, there are over 300,000 machine learning models publicly available on Hugging Face alone? 300,000. The barrier to using powerful ML is basically zero now. The barrier is knowing which one to grab and what to do with it. Quick note: if you're finding this useful, subscribing literally takes 2 seconds and it genuinely helps me keep making structured content like this. There's no fluff here, just the real curriculum. Now, back to building your playlist. The third pillar of any serious ML playlist is data, specifically, how to handle it before you ever touch a model. Here's a stat that will reset your expectations. Data scientists spend approximately 80% of their time cleaning and preparing data, according to a survey by Crowdflower. The model is almost the easy part. The hard part is getting the data into a state where the model can learn from it. Your playlist needs at least 2 dedicated videos on data preprocessing. You need to understand missing values. Do you drop rows, fill them with the mean, or use a smarter imputation strategy? You need to understand feature scaling, why a neural network trained on unscaled data where one column ranges from 0 to 1 and another ranges from 0 to a million will perform terribly. You need to understand train test splits. The reason you hold back 20% of your data before training is so you're testing your model on data it has never seen. If you test on training data, you're essentially letting the student grade their own exam. The specific library you'll use here is Pandas for data manipulation and scikit-learn's pre-processing module for scaling and encoding. These aren't optional extras, they're the foundation. And here's where it gets interesting, because once your data is clean, the next question most people ask is, which model do I pick? And the answer is not what you expect. You do not start with the fanciest model. You start with a baseline. Always. Before you build a neural network, build a logistic regression. Before you build a random forest, build a decision tree. Why? Because if your fancy model only performs 2% better than the simple one, maybe the simple one is the right call for production. It's faster, cheaper to run, and easier to explain to a non-technical stakeholder. This is called the model selection process, and your playlist should walk through it methodically. Use scikit-learn's built-in models, logistic regression, decision tree classifier, random forest classifier, gradient boosting classifier. Run them all on the same dataset. Compare them using cross-validation scores, not just single train test splits. A single split can get lucky. Cross-validation, specifically k-fold, where k equals 5 or 10 averages performance across multiple splits and gives you a much more honest picture. The playlist should then move into neural networks, specifically through PyTorch or TensorFlow. PyTorch has become the dominant framework in research, used by Meta, and it's increasingly the default in industry too. TensorFlow with Keras is slightly more beginner-friendly for syntax. Either works. Pick one and go deep rather than skimming both. Now here's the reveal I promised at the start, the concept most beginners completely skip, the one that separates tutorial watchers from people who actually ship ML products. It's deployment. Specifically, how to take a trained model and make it accessible to the real world via an API. Everyone learns to train a model in a Jupyter notebook. Almost nobody learns to serve that model so that a web app, a mobile app, or another service can actually call it and get a prediction back. This is the step that makes you genuinely valuable in a job, in a freelance context, or building your own product. Here's the practical version. Once you've trained your scikit-learn or PyTorch model, you save it using joblib for scikit-learn models, or torch.save for PyTorch. Then you wrap it in a FastAPI application. FastAPI is a Python web framework that lets you create an endpoint in about 20 lines of code. You send it a post request with your input features, it loads the model, runs the prediction, and returns a JSON response. You can then host this on a free tier of Render or Railway in under 10 minutes. Most people finish 100 hours of machine learning tutorials and still can't answer the question, how do I let someone else use this model? Now you can. That's a real skill gap you've just closed. Here are your 5 actionable steps for today. 1. Install Anaconda and open a Jupyter notebook. Run the iris classification example using scikit-learn's kneighbors classifier. 5 lines of code. Do it today. 2. Watch one video specifically on pandas. The read_CSV, dropna, and fillna functions are your most used tools for months. 3. Set up a Kaggle account. It's free. Pick one beginner competition. The Titanic survival prediction is the classic starting point, and run a baseline logistic regression. 4. Spend 1 hour with FastAPI. Build a Hello World endpoint, then swap in a saved scikit-learn model. 5. Bookmark the Hugging Face Model Hub. Even if you're a beginner, browsing it rewires how you think about what's possible. If this video saved you an hour of figuring out the wrong curriculum, subscribe. I post every week, and the next video in this series covers how to actually read machine learning research papers without a PhD, which is closer than you think. One question for the comments: what's the concept in machine learning that you've always been afraid to tackle? Drop it below. I read every comment and your answer genuinely shapes what I make next.